All right, so we're back again. And if you look at this, it says, this is an example problem. It says A is in the pocket of the man. Okay, so notice you see A is pointing to this right here. C is on the woman's racket. So C is right here, and that's actually on her racket. All other balls are on the court. Now, if you want a picture of this, a better picture, you can go to page 30. It's the same thing, but if you look at page 30, we need to name 3 balls that are collinear. So 3 balls that are collinear. Yeah?
E, F, and G.
E, F, and G. They look real close like they're on the same line. E, F, and G, would you think those are collinear? I'd say those are pretty close to being on the same line.
B, D, and G.
E, F, and G. You said, what did you say?
B, D, and G, maybe.
B, D, and G, if you extend them with those might work too. But basically, we're looking for 3 points that when we line them up, they are on the same line. Name 3 balls that are coplanar, but not collinear. Coplanar means on the same plane. Yeah?
B, C, and D.
B, okay, now where's C?
Does that not count?
B and D will
Okay.
work. I'll give you B and D. Pick another one then.
G,
E or F? B, D, and E? B, D, and F will work. So basically, it's any balls that are on the ground, but not B, D, and G, or E, F, and G. So another one you could do would be G, D, E. D, G, F would work good. Okay, so let's look at this next one. Name 4 balls that are not coplanar. So basically, let's use some rational thought here. We have B, D, and E we know are coplanar. So let's pick another ball that's not on the ground. So what would that be?
C.
C. Okay, so basically you could do B, D, E, and what would another one be? A. So you see how that kind of works? You could do A, C, B, E. There are a ton. A, C, B, E. That are not coplanar. Oops, sorry. Let's look at another example. Actually, I take that back. We're going to look at a definition. Okay? We're going to talk about a line segment. A line segment is basically 2 points called endpoints and all the points between them. 2 points called endpoints and all the points between them. We name the line segment by 2 endpoints. Okay. So 2 points called endpoints and all the points between them. We name a segment with 2 endpoints, name them by the 2 endpoints. So if I look at that diagram, AB, that would be called segment AB. Anything else that could be called? Segment BA, good. And then if we remember our line terminology, when we did a line, what would be another way we could write that? Yep, good. Yep, the little symbol. And so that's why I said be careful about putting arrows, because notice here now we've got segments. So we've got a point, a line, a plane, and now a segment. And we're not done, because we also have another one coming up. I said a lot of definitions. Point, line, plane, segment. We've got collinear, coplanar. And the next one, okay, we're going to now look at measurement. Now this is taken from your book a little bit. Okay, basically what you need to understand here. This is something, I don't know if you necessarily need to write that down as long as you pay attention. They are saying that AB equals 2 inches, measure of AB equals 2 inches. Okay, so notice what that little m means here. That m means measure. Notice the difference between the two. AB without the symbol, you just say AB equals 2 inches without the symbol. The measure of segment AB equals 2 inches. So notice here there is a symbol. So whenever you have the little m for measure, you need to have the symbol. So it's either simple or kind of complex. So down here, simple, mn is 5 units. Complex, whenever you see the m, you've also got to have the symbol. Okay? Let's look at the next one. Congruent. Geometrically equal. All you need to remember from here is that congruent means geometrically equal. Now some people say that congruent means equal. Struggle with that because congruent actually refers to geometric shapes. So geometrically equal, I would much prefer that you remember congruent that way. Now in this diagram, you've seen this stuff before, I'm pretty sure. And so if you look at this, these two single tick marks just mean that those two segments are the same. They're congruent. Here, 2 tick marks here correspond to these 2 tick marks here. Those sides are the same. So if this side was 4, this side has to be 4. The 3 tick marks here mean that these two segments are congruent. If this is 6, that side has to be 6. So that's what congruence is. Now notice, we have a symbol for congruence. Our symbol for congruence is a little squiggle with an equal to sign. And this means congruent. So basically, it's an equal sign with a little squiggle above it. That's what congruent means. If we are referring to anything with shapes, we use congruent and not equal. Okay, so that's kind of something to get down. You're going to probably want to get the symbol for congruence down. So, midpoint. A midpoint is a point in the exact middle of a segment. You pretty much know about midpoint. The thing here that I want you just to recall and remember is that a midpoint bisects a segment. Okay, that's the point that I want you to get here. A midpoint bisects the segment. Let's review what bisect means. What does bisect mean? What does bi mean, the prefix bi? 2. Sect is sections. So 2 sections. So when it says bisect, whenever we refer to bisect, that means cut it into 2 equal parts. So when I say a midpoint bisects a segment, I mean that a midpoint cuts that segment into 2 equal parts. Next we have an example. Okay, name each midpoint and the segment it bisects. So now be careful because some of these are deceiving. Do I have a midpoint anywhere on any of those diagrams? The first one, F. F is the midpoint of what segment? F is the midpoint of what?
P and G and C and D.
Are you sure? I will buy that it's the midpoint segment CD, but we don't know about EG. We don't have any measurements about EF and FG. Yeah, it looks like it is, but in geometry, it doesn't matter if it looks like it is. You have to be able to prove it. Here, I know that this is 2 and this is 2, so I know that's in the middle. I don't know about EF and FG. That could be 1.9 and 2.1 for all we know. Unless it's marked, you can't assume. All right, do I have another midpoint? K. K is the midpoint of what? JL, because of those 2 sets of marks. Okay. What about N? No, because you don't have anything marked. Okay, name all congruent segments. Use the congruent symbol to write your answer. So first of all, I'm going to do one for you so you can kind of get the... There you go. Segment CF is congruent to segment FD. What would another set be?
JK is congruent to KL.
Good. JK is congruent to KL. What's another one? There's one more.
JH.
Yep. JH is congruent to HL because of these segments. All right? Just got a little bit left and we're about done, folks. Okay, we're going to define a ray and then we're going to be done. Okay, so we'll get this down. A ray is half a line. It starts at a point and extends forever in a direction. Now notice in a direction, so in one direction. A ray is half a line. It starts at a point and extends forever in a direction. Now how we name a ray is we name it by the end point and any point on the line. So we name a ray by the end point and any point on the ray. Now, one of the things you need to understand is when we write that ray, that little symbol, they need to correspond. So if A is the end point, it needs to appear right here like it's on the end point. If B is on the rest of the ray, that needs to appear underneath the arrow. Down here, notice B is the end point, so notice B comes first. B comes where the point is on the ray. And then A is the way it extends indefinitely. So that's kind of one of those terminologies. This would be read as ray AB. Down here would be read as ray BA. So, basic building blocks of geometry are what three?
You have a segment.
What three?
Point,
Line, and plane. Okay. So, believe that's it. And there's your assignment, pages 33 through 34, 1 through 31. Now that sounds like a lot, but if you look there, you'll probably be able to get most of it done before we leave today. So.